This is Algebra 2, Lesson 5.3. We're solving quadratics by finding square roots. This is part number 2. We're picking up on example number 2 where we're solving a quadratic equation. We have the quadratic equation that says 1/2 times x minus 2 squared is equal to 8. You have to remember your order of operations for this. You have to remember to work your order of operations backwards. Do any subtraction and addition, then do any division and multiplication, then do any exponents or radicals. Remember, that's what we talked about yesterday. We added in exponents and radicals there, and then do anything that's in parentheses or any grouping symbols. So what you want to undo is any subtraction or addition. Now, it says x minus 2 in there, but notice that x minus 2 is inside parentheses. So you have to wait all the way to the last step to do that. The next step is to undo any division and multiplication. Well, we have some of that. We have 1/2 times what's in parentheses. Now, you could distribute 1/2 to it, but it's not necessary because it says 1/2 times that. That means to divide by 1/2 to undo it. Remember, dividing each side by 1/2 is the same thing as multiplying by the reciprocal 2 over 1. So multiplying by the reciprocal is much, much easier for most of us. Multiply this side by 2. That's the same thing as 2 over 1. And multiply this side by 2. So this will cancel out this. And 8 times 2 will give you the number 16. So now notice what you got. You got rid of that multiplication of 1/2. So x minus 2 squared is equal to 16. So now there is no more multiplication and division to undo, but they have exponents to undo. This is what we talked about yesterday for those few of y'all that missed it. Undoing the exponents. You undo squaring something by taking a square root of it. So it says x minus 2 squared. You take the square root of that side, and it cancels this. That's the reason you did it. Remember, anything you do to one side, you do to the other side. So taking the square root of both, notice this little symbol right here in front of the radical. Positive or negative. Just makes it to where you don't have to write the problem out again. Okay? There'll be times where we have to write it separate because we'll come out with a completely different number when we do so. And other times we'll simply be able to write both positive or negative because it'll just make it where we don't have to write it twice. So now you have x minus 2 is equal to both positive or negative 16. So right here, if you add 2 to both sides, so then you undo again x minus 2 because you got down to the parentheses step. There is no more parentheses. You eliminated it when you got rid of x, the squared by taking the square root. But it becomes x minus 2 again, so add 2 to both sides. That's just a regular Algebra 1 problem. Is equal to 2 plus or minus 4. So if you add 2 and 4, this is where these two numbers come from, negative 2 and 6. If you add 2 and 4, you get 6. If you say 2 minus 4, you get negative 2. That's why the two solutions are negative 2 and 6. Most people, when they get down to, and then the last part says, check the solutions by either by substituting them in or graphing them and observing the x-intercepts. When you sub them in, now this last part, what you're going to do is you're going to check for something called extraneous answers. Sometimes, and it'll almost always be because of negative values. Sometimes when you plug them back in, you don't get an answer that works. You get something that comes out to be one side will be positive and the other will be negative. That's called an extraneous answer. So like let's say if we plugged both of these numbers in, negative 2 and 6, negative 2 came out to be something that worked. Like if we plugged it in right here, negative 2 minus 4 is 2 is negative 4. Negative 4 squared is 16, and half of 16 is equal to 8. So that's a true statement. But let's say 6 didn't work. Let's say when we plugged in 6 right here, 6 minus 2 is 4. 4 squared is 16, and half of 16 is 8. Let's say it came out to be negative 8 minus is equal to negative 8, or both of them are equal They don't both give you 0. Then you would just eliminate one of the answers and you would say -6 does not work in that case. But what I was saying a second ago, most people at this step here prefer to write this as two separate problems. It's easier for a lot of people. I guess even a step right above that here. Most people prefer just because it's easier to organize it. X minus 2 equals 4 or x minus 2 equals -4. Most people just prefer to write it as two separate problems to where they don't make a mistake right there. But either way works. Then you just know to add 2 to both sides and you get both 6 and -2. So on the back, let's do this one. 3 minus 5x squared equals -9. Remember, undo your order of operations backwards. Undo subtraction and addition first, then multiplication and division, then exponents, and then parentheses. Remember, for exponents, that's where we put the radical step. Let's take about a minute, see if we can handle that one. Okay, went a little long right there. Remember, work your order of operations backwards. You're still doing it just like you've always solved equations. We're just adding in one more step that you're not typically used to. We're still trying to get x equals right here. And we're still doing any addition and subtraction first. So it says 3 minus 5x squared. The minus in between those two tells you that there's addition and subtraction going on. But the negative doesn't tell you. You don't undo it by adding. This is positive 3. You undo that by subtracting. If you subtract something from the left, you do the exact same thing to the right. Remember, you always do the same on both sides. So that'll eliminate it on the left and leave you with -5x squared. Don't lose the negative. Is equal to, you have -9 minus 3. Those are the same sign, so add them up. 9 plus 3 is 12, and keep the common sign, -12. Now what you have is -5 times x squared is equal to -12. So you have to undo. There's no more subtraction and addition. Now you have to undo multiplication and division. So -5 times x squared, you undo that by dividing by -5. If you divide the left, divide the right. Remember, a negative divided by a negative, same sign, is going to be a positive 12 over 5. So now what you have, that's going away. What you have is x squared. So we don't quite have x all by itself. We don't have any more multiplication. We move on to the next step, exponents and radicals. You undo x squared by taking the square root of it. Remember, if you take the square root of one side, you have to take the square root of the other side. This will cancel out and leave you with x. That's what you were trying to get. It's equal to the square root of 12 over 5. Remember, this is not an acceptable form of an answer. You cannot have a fraction under a radical. So the first thing you want to do is just separate it. This is the easy part. Separate it into the square root of 12 over the square root of 5. Rationalize the denominator to get rid of the square root of 5 at the bottom. That's not acceptable either. So whatever's on the bottom, the square root of 5, multiply it by that over itself. When you multiply it on the bottom, you'll have 5, and you have the square root of 12 times the square root of 5. Now, we can make that into 60 by multiplying those two together, or we could break down the square root of 12 to make smaller numbers. Remember the perfect squares: 2 times 2, 3 times 3, 4 times 4, 5 times 5. 4 multiplies by 3 to give you 12. So that becomes 2 times the square root of 3 times the square root of 5. And when you multiply the square root of 3 and the square root of 5 together, you get 2 times the square root of 15 over 5. So x, and this is an acceptable form, is equal to 2 square root of 15 over 5. The last thing you have to check is make sure you can't reduce 2 over 5. Like had that said 2 over 4, you would reduce it and make it say 1/2. But it doesn't, so you can't. Here's another one. Try this one. Take about a minute. 3. This one's a whole lot more like the example we just looked at. 3 times x minus 2 squared is equal to 21. Okay, let's take a look at this. You can't, some of y'all are distributing right away, and that's, I can understand that mistake. The reason you cannot distribute is because order of operations says you have to do exponents first. So you would have to do x minus 2 times x minus 2 first before you distribute it. Because remember, multiplication comes after exponents. So this is considered simplified on the left side. So start undoing it. I know that's a little different. So use addition and subtraction, or undo addition and subtraction first. You can clearly see it says x minus 2, but it's in parentheses, so you can't touch that minus 2 yet. So go to the next step, multiplication and division. You can clearly see it says 3 times that set of parentheses. That's the things that some of y'all are trying to distribute. So undo 3 times it by dividing by 3. If you divide the left, divide the right by 3. This cancels out. X minus 2 squared is equal to 21 divided by 3 is 7. So now undo squaring something by, go to the next step and take the square root of it. This will cancel out this and leave you simply with x minus 2. And then if you take the square root of the left, you do the same on the right. That's where we come up with the square root of 7. So this is what I meant by there's some more to it, because it doesn't just say x is equal to that. You got one more step to do. Now you undo the addition and subtraction, since we got to that parentheses finally, by adding 2. If you add it to the left, add it to the right. Now you cannot add these two together and get any form of the number 9. Just like you can't add 7x plus 2. They're not like terms. So right here, this would simply be x is equal to the square root of 7 plus 2. Or more specifically, it would be both positive or negative the square root of 7 plus 2. But again, we'll deal almost exclusively with primary square roots, the square root of 7 plus 2.